Hello everybody. Today I'll be talking about doubly linked lists and how to implement them in C++. A linked list is a linear data structure that is made up of nodes, and each node can carry a reference pointer to the next node. Or if it's a doubly linked list like we'll be doing today, it can carry two reference pointers to the next and the previous node. So to give you a visual idea of what they might look like in memory, we can use diagrams. So let us assume that each box I draw here is a node in the linked list. So each of this node can have a pointer to the next and one to the previous, and this one too can have a pointer to the next and this one to the previous. But in this case, this pointer is going to be a null pointer because there is no node before the first node. It doesn't point to any node. And this last node is going to have a previous pointer, and here is going to have a null pointer too because it doesn't point to any node. So this can be null pointer. So like I said, each node can carry data that's like some value data, and here's going to be next, and this is going to be previous, and this is going to be next and previous, just like that. Next and previous. So that is what it might look like in memory, just to give you an idea of what a linked list looks like. So now that we have a better understanding on what a linked list is, let us implement one in C++. I'm going to be doing so in an object-oriented fashion. So I'm going to make a struct called one_char, and I'm going to be making a linked list of characters. That's why I've chosen the name one_char, like letters A, B, C, D, E, to make like a word. And this struct is going to be a template for each node. So like you see, it's going to have a pointer to next, previous, and the actual data that each node carries. And this I'm going to call I. And of course, I'm going to make a class. I'll name it word. And as a private data member, I'll put the head in here. I'm making it a private data member because, like I said, we don't want to lose the head, like traverse it or mistakenly delete it. That's why I'm making it private. And here, of course, I'm going to make my constructor. Just so I don't forget. And let us make some utility functions. I will make one called getHead. It just returns the head. I can't type. Kind of nervous. No, not really. And I'll write another one called is empty. It just returns true or false if the linked list is empty. Yes, so this is our foundation laid for the linked list. Now we can make the first actual function that manipulates the linked list, which will be insert@head. And of course it's going to take an argument, which is the data that the node will carry. And the first thing we want to do is make a node. Here I'm going to call it temp. I'm going to use the new keyword to make one. Can't type. Okay, so temp ROI is equal to x. So this is actually filling up the node with a value. So each node you create will have previous, next, and a value. So I'm making I, which is here on line 7. Yeah, I will be, the value will be x, whatever you pass in as an argument to this function. And the first thing we want to do is check if the linked list is empty. If it is empty, we're just going to make this temp node the head, and we're done here. We return, we call it a day, and our job is done here. That is if the linked list is empty. If it is not empty, next equal to head, or make heads previous equal to temp. Head our previous, we'll make that equal to temp, and we'll just make head equal to temp. So if this is confusing, I can show you with a diagram. Let's get rid of this. So what is this is doing is so this is a node, right? And this is another node, back and forth like that, and this is head, and of course there's a pointer to head that says head. And line 29 28 we created a node called temp, and each node has a previous and a next. So on line 35 we say let's temp our next equal to head. So temp's next pointer should point to head, and let head's previous pointer point to temp. And now this head pointer that originally points to head, which is the first node, on 37 it should no longer point to head, it should point to head, making it should no longer point to head, it should point to temp, making temp the head node and the first node. So you see how this three lines 35 through 37 makes temp the head of the linked list. That is how it works. Now we can make a function that is going to print the linked list, so we can actually see the nodes we are inserting into it. I'll call this print. Of course it's not going to take any parameter, and of course we're going to check if it is empty, because if it is empty there is nothing to print. So we're just going to return if it is empty, and our job is done. If it is not empty, we're going to make a pointer to head called whatever, but I'm going to call it current. And I'm doing this because I don't want to actually use my head node to traverse the linked list. Like I said, we shouldn't do that because the head is like a secret node. It should be respected at all times. So while you are not at the end of the linked list, like while you're not while the current node that is traversing through is not a null pointer, we are going to see out the value in each node. So like our I, and I'll end line just to make it look prettier when it prints, and we're going to jump to the next one just like that. Then I think we're ready to actually call the functions. So I'll call it letters. So I'll say letters inserts. Nope. Oh my god, I can't type. Inserts at head. I'll say A. And do this like 3 times. And this will be B, and this will be C. And of course I want to print it. Okay, let's see this in action. So yeah, you see it prints ABC. Well, it looks like it's reversed just because the first thing to be added to the linked list was A, then B was added next, then C was added next. That's why it's like it prints reverse, but this is actually correct. So this is how we insert into a linked list. We can do another function to insert at an index. Let's say set at index, and this one will have two parameters: the actual value you want to insert and the position you want to insert, and it's going to be, yeah, an integer position. And the first thing we want to do, as always, is create the node we're going to be inserting. We're going to fill it up with x, and of course we want to say if it is empty. We want to just make, I know this function is not supposed to be making anything at the head or inserting at the head, but if it is empty and you want to insert an index, in the first place you're going to hit is the head. That's why I'm making it the head. I'm going to make a pointer called current, points to the head, because we have to traverse to the index we want to insert at. Here I'm going to use a for loop because it's going to be dependent on an input from the user at where you want to insert. So a for loop is better in this kind of scenarios. So I less than the position minus 1, and I plus plus. So while this for loop is doing this thing, we want to jump to the next. So when we finally get to the point where we want to the index, we want to manually make the node, we want to manually put the node at that index. How are we going to do that? We're going to say temp arrow next is equal to current arrow next. Then we're going to say current arrow next is equal to temp. And then we're going to say temp's previous is equal to current, and temp arrow next arrow previous is equal to temp. If this does not make sense, I'm going to explain. So what we're doing on line 67 through 70 is this. If I can find my, okay, here. Let's look at it. So let us see how the insert at index works. So, oops, here, each node, each box here is a node, right? And let us say this is the index we want to insert at, and this is current, which is the pointer that was traversing the linked list. And let us make our node called temp, which we want to insert at this index. So line 67 says temp arrow next equal to current arrow next. So temp arrow next is going to point to this guy, because this is current, and current arrow next points to this node, and we want temp arrow next to point to current arrow next. Line 68, current arrow next is equal to temp. So current arrow next, this guy, is equal to temp. You see that? Then temp arrow previous is equal to current. So temp arrow previous is going to equal to this guy. Then temp arrow next arrow previous, temp arrow next, this arrow previous is equal to temp. So this node is no longer current arrow next because we reassigned it on line 68. So we cannot refer to this node as current arrow next anymore. That's why line 70 looks longer, because the way we can refer to this node is temp arrow next. So we're going to make the previous pointer of this node equal to temp. So we've reassigned the 4 pointers that connect this. So this connection here does not exist anymore, and temp is going to be inserted at this index. Of course, let's see how it works. Let us make insert at head longer. Okay, so now we have 5 characters, and let's insert at index. So we can say letters the inserts at index And let's insert something that's going to stick out. Let's insert a Z at the third index, and let's call it. Oops. Line 55. Oh, I missed my I there, that's why. Sorry about that, guys. Errors, it's a given. To be expected. Hopefully it works this time. Record is so slow. Yeah, now you see that Z got inserted at the third index. 1, 2, 3, right there. So it works. So now we're ready to make our last function for this insert series, and I'm going to insert at the tail. And of course it's going to take an argument, which is the character you want to insert. As always, I'm going to make the node, call it temp, use the new keyword. I'm going to fill it up, and I'm not going to make the same mistake I made the last time. Nice. We're going to say if it is empty, we're going to make this node the head, and we're going to call it a day. If that is not the case, we're going to use a while loop to traverse to the end of the linked list, which is the tail, and we're going to insert there. I'm going to make a pointer to the head called current. Like always, I don't want to traverse with my head because it's sacred. And I'll say while current our next is not equal to a null pointer. So I'm saying current our next because I don't want to get to the null pointer. If not, there's nothing I can do. I want to be just before the end of the linked list, like the last node, and then insert there. If I get to the null pointer, there's nothing I can do. I can't. There's no room. There's no wiggle room there. So I'll just say current equal to current our next. This is how I'm going to traverse, and then when I get to the end, I'll say current next should be temp. And temp's previous should be current. Yep, this will do the trick. So here we can say insert a tail. Let us insert the letter R at tail. Let's call this function. Oh, line 84. Yeah, sometimes I get lazy because I started writing in JavaScript and I forget the semicolon sometimes. But I think that should be it, and this should work. Cool. Now we see R right there, and it doesn't even matter like where you call this function. I can put it right in the middle. It's still going to be the same thing because it's always going to insert at the tail, just like that. So to see a visual representation of how that worked, so at the tail, so this is our node, yeah, and this is current, and this is a null pointer. Nothing is there, and this right here is temp. We want to insert a tail, right? So line 86 says let current RNX equal temp. So this current RNX is equal to temp, and let temp's previous equal to current. So this is how the connection is made, and this guy would be the new node at the tail. And of course, the next pointer of this node is going to be a null pointer. So that's going to be it for the linked list series. The next one I'll do will probably be removing from the linked list. I hope you guys enjoyed and learned a lot about linked lists. See you guys next time.